Test corrections. Here we go. X squared, y squared, both positive, same number. Circle. 9x squared, 4y squared, both positive. Ellipse. Now for part C, we need to put this in the general form, so we're going to start by completing the square. So let me rewrite the equation over here. And as I rewrite it, I'm going to group it so that I have my x's together and then my y's together. And I'm going to move the 16 across the equal sign. So now I need to add a box. So a box for the x's and a box for the y's. Now I'm going to factor out a. And I'm going to factor out the 4 over here. And now drop this down, cut it in half, and square it into the hole. Plus 4, plus 4. Now I have to make sure I add the same thing to the right hand side, so that's not really a plus 4, it's multiplied by 9, so it's plus 36. And this is plus 4 times 4, so plus 16. So those add up to, the 16s cancel, 36. And now I'm going to factor the other side, so don't forget the 9. And we just bring this minus 2 down, so x minus 2 squared on the outside, plus 4, now the positive 2 comes down, y plus 2 squared on the outside. And it's not quite in standard form, I need to divide by 36. So I get x minus 2 squared over, and 9 over 36 will reduce to 1/4. And then the 4 over 36 will reduce to 1/9. So we have a 9 on the bottom. Like so. There's standard form. Now, I'm going to graph this. So my center is at 2, negative 2. Let me rewrite the equation. X minus 2 squared over 4 plus y plus 2 squared over 9 equals 1. So again, center at 2, negative 2. So there's 2, negative 2. And then we're going to count up, we'll call that B and that A because 9 is bigger. So in the y direction, we're going to count up 3 and down 3. And in the x direction, we're going to count right and left 2. 2 that way, 2 that way, and there's my ellipse. And to put the foci in the right place, we'll do a squared minus b squared. So 9, 3 squared minus 2 squared, 4 equals c squared, so c equals the square root of 5, which is about 2.2. So a little bit past 2. And there's my foci. Section 2. This x squared, y squared, one of them's negative, is a hyperbola. And this x squared, y not squared, is a parabola. So we're going to put the equation A into general form. So to do that, we need to divide by 60. So it's going to look like this. X plus 3 squared, and 15 over 60 reduces to 1/4. So 4 on the bottom, minus, we're going to have the y plus 2 squared on top, and then 12 divided by 60 will reduce to 1/5. So a 5 on the bottom. and that equals 1. And we're done. And now we're going to graph it. So it's a hyperbola. Let me write the equation over here. Let's start with the center. It's at -3, -2. And now we use the positive side as a. So a is 2. And since it's underneath the x, we count in the x direction. 2 that way, 2 that way. Those are our vertices. Now, b here is going to be not 5, but the square root of 5, which is about 2.2. So for those values, we count up not from the center like we do in the ellipse, but from the vertices. So up and down 2.2. And then we use those values to draw in straight edge, our asymptotes. Nope, bad idea. I'm just going to freehand it. Asymptote. Asymptote. And so our hyperbola is going to go out from the vertices and approach the asymptote in each direction. Now to find our focus. For our focus, we use a squared plus b squared equals c squared because c is the longest here. The foci are outside the vertices. So a squared plus b squared equals c squared. That's 9. Square root c is equal to 3. So it's going to be 3 away from the center in each direction. So out 3 that way, there's the focus. Out 3 that way, there's our focus. And then for the asymptotes, let's write out the equation. So it's going to be y minus y1, which is the y value of the center, -2. So make that y plus 2 equals plus or minus. We'll get the slope in a second. And then that times x minus x1, which is the y value of the x value of the center, which is -3, so x plus 3. And then to get our slope, we look at the a and the b. So a is 2, that's the run. B is the square root of 5, that's the rise. So the slope would be the square root of 5 over 2, the rise over the run. Section 3. This one's going to take a little bit longer. Let's start here. To graph this circle, we want to put it into standard form. That means we need to divide everything by 2. X squared plus y squared equals 25. That's a circle centered at 0, 0. And the radius is the square root of 25, which is 5. So out 5 in every direction, and make a pretty circle. Next, we want to put this in general form. To do that, we need to complete the square. So start by moving the 20 over, and then we're going to regroup these with the x's and the y's together. So 2x squared minus 4x, leave a box, plus 2y squared plus 16y, plus box. I'm going to go over into the other problem a little bit, equals 20. Now I need to factor out a for both sides. So factor out the 2, x squared minus 2x plus box. Factor out the 2 again, y squared plus 8y plus box. And now I need to fill in that square hole. First, I drop this down and halve it. So there's -1, there's 4, and then square it. So I'm going to add 1 there and 16 there. Now, instead of adding 1 and 16 over here, they're both multiplied by 2. So I need to add 2 and add 32. That gives us 54. And now I'm going to factor each side. So don't forget your 2's. And then the factor is going to be x, and drop that number down, minus 1. And drop this number down, y plus 4. Plus 4. Now it's not in standard form. This is a circle. We want to have no numbers in front of the x and y, so we divide everything by 2. X minus 1 squared plus y plus 4 squared equals 27. So it's a circle centered at 1, negative 4 with a square root, with a radius of the square root of 27. C. Here we know that d1 plus d2 should equal d3 plus d4. That's going to be our equation set up. So 2x plus 14 equals 5x plus 9, and we solve. So I'm going to subtract the 2x over this way and subtract the 9 over that way. I want to get my x's together and my non-x's together. So 3x equals 5 divided by 3. X equals 5/3. Okay, D. So we're going to graph the vertex. It's at 1, 2. And the focus is at 2, 2. That means the distance between those, which is P, is 1. So P equals 1, important value we're going to use there. So P is 1. That means to find the directrix, we're going to count in the opposite direction by the same amount, 1. So the directrix here is actually going to be on the axis, on the y-axis. Then the axis of symmetry goes right through all those points. So this would be x equals 0. It's a vertical line. And this would be y equals 2. That's our axis of symmetry. And now we need to graph it, but we don't just want to draw a random parabola-looking thing. We want to graph it accurately. So again, we use this value for p, and we count, in this case, up and down from the focus by 2p, which would be 2. So we're going to count down 2, and then up 2. Up 1, up 2. That's the latus rectum. And now our parabola is going to go through those points. And now it's accurate. Yay. Now before we do E, we need to do G. So let's do G first. So G asks for the focal length. To get the focal length, we use this little shortcut, 1 over A equals 4p. Again, that's only because this is in ax squared plus bx plus c form. That's why we're using this shortcut. So A would be 2, B would be 3, C would be negative 4. So to get the focal length, we're going to plug in 2 for A. So 1 over 2 equals 4p. Now, to solve for p, we need to divide by 4. But an equivalent but more useful way to do that would be to multiply by 1/4. That still cancels out the 4, but that makes it easier to deal with this side. So 1/2 times 1/4 would be 1/8, and that's p. Now, another question about part E, about question G, which is part E. We want to find the vertex of the parabola. So we're going to start off by using this shortcut, again because our equation's in that ax squared plus bx plus c form. So h equals negative b over 2a. Now, let's go back over here. B would be 3, a would be 2. That comes from this other equation. So that's negative 3 over 2 times 2. 2a. 2 times 2, which is 4. So there's h. That's the x value of the vertex. We want the y value of the vertex. So the way we relate x values and y values together is by using the actual equation itself. So x would be the x value of the vertex. We're going to plug in negative 3/4 there. So I'm going to write it down. I'm plugging in 3/4 for each of these. So it's 2 times negative 3/4 plus 3 times negative 3/4. Sorry, I forgot to square the first one. That's 2x squared plus 3x minus 4. And it equals y, and the y value is going to be k. So again, to find k, we just plug in h as the x value to the equation. And now we just have to do a little bit of fractioning. So to square a fraction, square the top and the bottom, that would be 9/16. And then multiply it by 2/1. So that would be 18/16. Here, make that 3/1. So we would get negative 9/4. But we want to scale it up to 16ths. So multiply the top and the bottom by 4. So instead of negative 9, we get negative 36. And I just put the minus out in front here. And this is 4/1. Again, we want to put it over 16, so we need to multiply the top and the bottom by 16. So the top, 4 times 16 would be 64. And again, I put the minus out in front. So this is k. Now we simplify. 18 minus 36 is negative 18 minus 64 is negative 82 over 16, which reduces to negative 41/8. So that leaves me with an x value for my vertex of negative 3/4 and a y value of negative 41/8. And that is my vertex. One more problem for this section. That's problem J. Okay. So for a parabola, what we know is that this distance should equal that distance. So distance 1 equals distance 2. So x squared plus 2x equals 5x plus 4. Now, this is a quadratic equation. So to solve this quadratic equation, we can do a couple of things, but one of them is to set it equal to 0 and try to factor it. That's what I'm going to do. So subtract the 5x and the 4 over to the other side. That's x squared minus 3x minus 4, and that's going to leave it equal to 0. And now we try to factor it, and this one will factor x minus 4 times x plus 1. Not sure how to factor it? Have fun with the quadratic formula. And so we set each factor equal to 0. X minus 4 equals 0 gives us x equals 4. And then x plus 1 equals 0 gives us negative 1. So we have two answers. Or do we? We need to make sure that both of these answers are valid. So check the 4. Plug it into the problem. 4 squared, 16, plus 2 times 4 is 8. That's 22. 24. And over here, 5 times 4 is 20, plus 4 is 24. So 24 for both distances. That works. Now, negative 1, if we plug that into distance 2, that would give us negative 5 plus 4, which is a distance of negative 1, which is not valid. So negative 1 does not work, only 4 does. So make sure and check your answers. Section 4. So on H, we've got a parabola, we're given the vertex, and we know it goes through a point. Now, I'm not going to draw this. To write this into standard form, we need to know H, we need to know K, we already have those are the coordinates of the vertex. Now we also need to know P. So to find P, we're going to use these two values over here. I'm going to call them X and Y. So some point that the parabola goes through. So in standard form, this opens vertically, so we're going to have the x on the squared side. And if you sketch these, you'll see that it opens down, so I'm going to put a negative out here. And then we get y minus k. And so, to solve for p, we just need to plug in values for all of the other coordinates. So h and k, of course, are negative 1 and negative 3, so change the signs there, plus 1, plus 3, since we're subtracting a negative. Then x and y, we're going to use the negative 2 and negative 5. squared on this side, not squared on that side. Don't be sloppy with your squareds. Equals negative 4 times p. Again, negative because I know it's going to open downward. So now all I have to do is solve for p. So negative 2 plus 1 is 1 squared, which is 1. Over here we have negative 4, and then p, that would be times 2. So that's negative 8. So we'll divide by negative 8. And p equals negative 1/8. So now I just plug that into the equation, and I did a great job of leaving myself plenty of space. Let me write it over here. So that would be x minus, oh, I left off that negative sign. Sorry, let me back up there. This would be negative 2 over here times negative 4, which would make that a positive 8. Okay, I thought it was weird that I got a negative. So that's positive 1/8. So x minus h, which is 1, so x plus 1 squared equals negative 4p, which is 1/8, times y plus 3. There's my equation. Let's do I. Here we want to give the equation of an ellipse with the center at 3, 4. 14 units across in the x direction, 20 across in the y direction. Okay, not drawn to scale here. So that's 14 across. And then this distance right here is going to be 20. So in other words, it's 20 this way. So 14 this way, 20 this way. Now, we know that the center is going to give us x minus 3 squared on this side, y minus 4 squared, and it should be equal to 1. But the question is, what are a and b? So, in the x direction, it's 14 units across. Now, remember, a is only halfway across. So a is halfway across. A is going to be 7. So this is a squared or b squared. It doesn't really matter which is which. This is b squared, I guess, because it's smaller. So b squared, 7 squared, that would be 49. Now, in the y direction, I guess this would be a because it's bigger. Since it's 20 units across, cut that in half, and a would only be 10. So then we square a and we get 100. So again, a is half the vertical direction, b is half of the horizontal direction. So cut those in half before you square them. Now, problem K. We want to give the equation of a circle with that center and that point. So the key here, we need to know what the radius is. So to get the radius, we're going to use either the distance formula, which you could do, or the Pythagorean theorem, which you could also do. Turns out it's exactly the same thing. So let's draw these. 3, negative 2, 1, 2, 3, down 2, and then negative 5, 5. So to do the Pythagorean theorem, I need my rise and my run. So my rise is, my run is 8, my rise is 7. And then this hypotenuse should be the radius of my circle. Okay, so 7 squared plus 8 squared equals r squared. Or in other words, we'll take the square root of whatever 49 plus 64 is, so 113. So 113 is the radius. Now, we come back, the square root of 113 is the radius. So we come back to plug in our formula. For a circle, we've got x minus h squared. H would be 3. Plus y minus k squared. So y minus negative 2, or y plus 2, equals the radius squared, so that squared would cancel out the square root of 113 and just leave us with a 113. And last problem, we want to give the equation of a parabola with that vertex and that focus. So this one's easy. We know h and k. We need to know p. So p is the distance between the vertex and the focus. How far apart are those 2 points? Well, sketch them out. There's 1, 2, and there's 1, 3. How far apart are they? 1. So I know h, I know k, I know p. Which way does the parabola open? It's going to open vertically, so I'm going to use x as my squared, x on the squared side. It opens up, so it's a positive 4 times p. P is 1. And then y minus k. Y minus 2. And there it is. Done.